In example 2, we're asked to find lateral and surface area of a right regular triangular prism with a height of 20 centimeters, base edge length of 10 centimeters. All right, first thing here, we should probably visualize what this looks like. And my suggestion would be to sketch it out kind of like this, where you almost have like a tent type object. Put dotted lines for the parts that you can't see. We know from our description, okay, right here it says right regular triangular prism. So what that tells us is that these, where the base and the lateral edges intersect, will be a right angle. Okay? The two bases here are the triangles. Okay? That description about it being a triangular prism, we know that the bases are the triangles and the lateral faces are going to be those rectangles. In this case, they're on the sides and the bases are in the front and the back. They are regular triangular bases. So another word for regular triangle is an equilateral triangle. So let's re-sketch this out where we're looking at one of these triangular bases. We know that the base edge lengths are 10 centimeters. So we have an equilateral triangle, and we've got 10, 10, 10 all the way around. And in general, we know that to find the lateral and surface area of this prism, we'll start with the lateral area. And the lateral area would be the perimeter of the base times the height. So the perimeter of this regular triangle would be 3 times 10. And then the height, we are told that the height of the prism, that's what this 20 centimeters refers to, is the height of this prism. Okay, so the length that connects the two bases would be 20 centimeters. So we can multiply these three values together. We know 3 times 10 is 30, and 30 times 20 is 600. So we have 600 square centimeters as the lateral area. Now to get the full surface area, we need to add on the area of the two bases. So let's come back over to our picture for our triangular base. We know that we're going to split that coming down the center with the height, and the area of a triangle we know is 1/2 the base times the height. Now be very careful. Don't just grasp at existing values for base length and height. Okay, if you're not careful, people are going to see, oh, there's a height of 20 centimeters. Let me substitute that in for h. That is referring to a different height. That is the height of the entire prism, which we said was 20 centimeters. Okay. With this problem, we are just referring to the height of this triangular base. So here is the height that we are interested in for this equilateral triangle. Now, using what we know about equilateral triangles, we have, in this case, our right triangular section. The hypotenuse there is 10 units, 10 centimeters. This height is going to run down perpendicular, so we have 5 centimeters down there for our short side, and we know that this is going to be a 30, 60, 90 triangle. So if we're good with our 30, 60, 90 ratios, this height calculation is very easy. Okay? We have our shortest side across from our smallest angle, the 30-degree angle, so that's 5. So our medium side is the height that we're interested in. We know that this is going to be 5√3 for our height. So we can substitute this back in. 1/2. Our base length is that full 10. And our height we just said was 5 root 3. So we can multiply these together, or what's really important is that we find the surface area for this full prism, and we know that we're going to need 2 of these bases to find our complete surface area. So we'll take our lateral area plus 2 times the area of the base, and we can substitute in our 600 square centimeters from the lateral area, and we have 2 of these bases. So we're multiplying all of this base area by 2. The 2 and the 1/2, they're going to multiply each other to 1. So really we just have 10 times 5 times the square root of 3. 10 times 5 is 50. So if we wanted a simplest radical form answer, we could think of this as 600 plus 50 root 3, but the directions tell us to round our answer to the nearest tenth, so we're going to type all this into our calculator. 600 plus 50 times the square root of 3, and our rounded answer to the nearest tenth would be about 686.6 square centimeters.